Okay, before going any further on any advanced topic or complicated topic, I need to give you an introduction to THREE.js. So I will just demonstrate for you the very basic that's even on your documentation. It's like how the things works together, okay? So to get started, we need to know that THREE.js works essentially with three components. He needs a camera, he needs a scene, and he needs a renderer. I will show you what are those and how to configure them. So once you are comfortable with those three components, it's pretty much very easy to get the head around the others. Okay, so let's start with creating a scene. So in THREE.js, everything is namespaced with tree. So everything will start tree and something. So I will create a scene. Go ahead and create a camera. So camera, it's gonna be, actually for camera we have a few options. We have a perspective camera, cube camera, orthographic camera, and so on. So pretty much the two cameras that you might be using most of the time would be a perspective camera, is like the ones that we see in real life, like our 3D vision is like perspective, and the orthographic camera is like a 2D camera. It's more for 2D animations, or maybe if you want to do some kind of UI, so you might use two cameras at the same time. It's totally possible. So we're gonna make our application using this perspective camera, and we need a renderer. So the renderer, we have also have a few. We have the Webgl Render, that is a web version of the OpenGL. So the one that we're going to be using will be this one, web renderer. And we also have this canvas renderer, that is this is basically the HTML5 implementation of these animations in 3D for the web. It's important to notice that they are actually different. If I use one renderer, means that some things that I might be using, like some 3D objects or some materials or something, it's specific for Webgl renderer. So it might not work. So the setup for those two kinds of render are different. So this course I will be focusing on just this Webgl render, and maybe in the future I might be doing one just focusing on the canvas render. So let's just get started with this one. Okay, so now that we have the three components set up, we need a loop that will run through update our code on every tick of a clock. So these concepts exist in pretty much any engines, game engines, or anything related to animations that you might see. It will have this loop logic. THREE.js is nothing different. It's also needs one, and we might be using the ones that's built in your browser already. So to do so, I will start with create a function here. Let's call it var loop, and create a function. And I will start it right after call it right after its creation, because it needs to be called every time. And then we're gonna be using this request animation frame, and for request animation frame we need to give a callback. Imagine this function here will be called 60 times every second. So I need to give a callback here. So the callback I will give is itself. So every second, every 1 second, it will call this function here 60 times itself. So it will be forever be calling this. I can show you, demonstrate you, if I just do this console and log and say hello, I don't know, and just refresh here my page, and you see I get in the output very quickly hello. I got many hellos. So it's just increasing the number here of calls. It's calling this, it's logging this in my console. So this is what this function does. So on every frame, every time this function is called, we need to call a render method on the renderer, that it will take care of updating the scene and the camera and any kind of objects that might be inside of this or on the field of view of the camera. So so I will give the scene that is already created, right? And also we will give the camera. Okay, so this is pretty much okay for this. And yeah, so if I save here and refresh my page, nothing will happen. That's because besides creating this camera, I need to append this object here that's the output of everything to somewhere, right? So I will append this to the body of my HTML page. So I can do this by doing basic HTML things like document.body.append child, and I can get the elements that I need to append to there by the renderer, and say DOM element. So this is the DOM elements that will contain the canvas. That's the Webgl will draw the animation that we are doing in it. So if now I give a refresh, I can see a black box here, the black rectangle. Yeah, but still there is nothing inside, right? Because we just have a scene, a camera, and a renderer. We don't have any object inside it. So the next step here is to create an object. So let's create one. There are a lot of primitive objects in THREE.js that we can start from. And the logic, the concept of creating objects is like this. We need the geometry that defines the object's shape, and we need a material. A material is like define the object colors, looks, and feel. It's in this meaning, in this sense. But materials are not necessary on every case, so we're not going to create one just right now, just to don't overcomplicate this example. But we're gonna average like pretty much everything in this course. So let's say I will first need my geometry, right? So my geometry is equal new tree dot. So we can use a lot of geometries that's available here, like box, sphere, cube. I don't know. There is a lot of geometries that we can use. I will be using one called box geometry, and if we see the source. It's expecting us to give a width, a height, depth, width segments, height segments, and depth segments. So pretty much just these three here is necessary. The others will have some defaults. So we just need to give the width, height, and depth. Pretty much is like a X, Y, and Z, right? So let's say I will give 10, 10, and 10. So it's pretty much a cube, right? The next step is to create a mesh. Mesh is like the container that will hold links together the geometry and the texture and material in this case. So let's say mesh is equal new tree.mesh. We have also a lot of kind of mesh. Some mesh will like try to simulate physics. Some meshes will be like we will accept some kind of shiny materials or this kind of things, but we just start with a basic one. So we will give the geometry, and the second argument would be the material. But I don't have one right now, so I'm not going to set. So by default, it will take a random material, a random color material. Okay. And the next step is, now that we have our object, we need to add this to the scene. The scene is imagine the scene as the container where we compose any object we want into it, and the camera will have a look to it, and everything the camera sees, it will output to the end user. So I can do this scene dot call the method called add, and give a mesh. That is what I want to add. So I can add many things. If I have the many meshes, I can go on adding. I just can't add 2 times the same mesh because it would throw an error because it's already there, right? You can't magically add something that was already there in real life, right? So if I refresh now, we still don't see our mesh created there. It's because the mesh position, that's default, that's I didn't set any position, right? And the camera position actually are the same. They are at the same point. So the camera can't look what is exactly the same the same spot, right? They are occupying the same space in the 3D world. So I needed to let my camera put out my camera farther a little bit. So I can do that by getting the position of my camera. So camera position dot the z position, right? I wanna is equal, I don't know, 100. So now if I refresh, I can see my cube there. I can see actually it's not really a cube, it's a little squeezed, but it's because we need to set some configurations in our camera to adjust the ratio between our screen and what we are seeing in the scene. So the next step is to fix that. So how to make this looks like a cube? The camera perspective camera, there is some options that we can set here. If I go to the camera class, you see here I can set the FOV, the aspect ratio, the near and the far. So let me copy these parameters back to our file here and set this to the camera. So the FOV is the vertical field of view that your camera can see. So we will set this like for 75 is like a default value, is that you will not feel the things are too stretched, or when the camera is too close to some objects it will like have some weird deformations. So this is a common standard value. The aspect ratio is the relation between the width divided by the height of your canvas. Right now we don't know the size of it, right? So I will just set here as 1 for now. So later I will tweak this a little to precisely have the ratio of my canvas. The near is how near the objects your camera can see. So if there are objects like 10 pixels in front of your camera, and you just want to allow objects like 20 pixels away, so you can set here like 20, for example, and so just objects after 20 will be able to be seen by the camera, others will just be invisible. And the far is just the opposite, like how far the objects you can see. After that limit here, it will be invisible for the camera. So for those values, I will set for the near 0.1 is like the minimum value possible to set to this. And far, let's say I will set 1000. So now I will give it my page a refresh. You see here, I can see my object is still there. But it's still not a cube, right? I create a cube here, and this is a perfect cube, 10 by 10 by 10. So I need to fix now my aspect ratio. So to do this in an easier way, let me create a container here to contain my canvas. So I will create here a div with ID container, and let me reference this, create a reference to this container here. So container is equal document dot query selector and a container, right? So we have here, and we here replace the document body with the container. So the container append child. So if we save this and refresh and see our element HTML here elements, we will see that the container now has the canvas inside it, right? Okay. Now we needed to correct the ratio, but let's first set some manual values here. So let's use the style, inline style here. So width of this will be, let's say, 300 pixels, and height also 300 pixels. So just make it to equally. And let's add a background color here for testing. So background will be, I don't know, yellow background. Okay. So I refresh here. You see my container is bigger, is taller here than my canvas. We can correct the size of our canvas to match our container by setting the size of the renderer. So before adding here the renderer to the DOM, before here we can set size, and give the width. That's in this case would be 300 and height also 300, right? So if we set here, so refresh, it will match. And because this is 1 by 1, is the ratio is 1, and 300 divided by 300 is 1. So we can see our cube is a cube, like is a square, right? We just now can say square, but it will be a cube soon. Okay. So, but then we have a problem. If we change, for example, the width to 500 and refresh the page, so the width of the renderer doesn't resize accordingly with the width of the container. So we need to make a way here that it will automatically get those values here. So to do that, I will use the container client width, right? Client width and container.client height here. So give a refresh, so it will always resize as my container. So if I change here any number, it will also be resized accordingly. But yeah, every time I resize it, I will lose my aspect ratio, right? Because now the width is bigger than the height. So my ratio is no longer 1. So pretty much I need to do the same logic I did here into my ratio. Don't worry that I'm inlining everything here. It's just because for sake of demonstration. Later I will break down the things into modules so we don't have to repeat ourselves like here. Okay, so it will be easier. So now if I give a refresh, I should be able to see the square, the cube. So now the next step is to make this cube move, right? So to make this move, we'll tweak the rotation, for example, as a test from the mesh. Maybe it's the easiest demo I can show you. So the mesh has a property called rotation. And the rotation contains X, Y, and Z. It's a vector tree with these three properties, X and Y and Z. So I will, for example, rotate the X to, for example, if I just add here, for example, X 10. You see it rotates a little, it's just changed its shape. If I give a X, I don't know, 13. It moves a little, and yeah, that's the idea. But I don't want to change it right here, right? I want to change it in the loop. That's what's the loop for. The loop will update these properties on the frame based, right? Every frame it will update this. So what I want here is every update I wanted to add 1. I add 1 number to the X. So when I refresh here, you see, but it's so fast. Let me bring this cube a little closer to the camera. So let's say I want a 20 here. So now it's a little closer, but yeah, it's too fast, way too fast, right? I will give a smaller number, like 1.0.1. So I refresh here. Okay, it's a little slower. Not just the X, let's also animate the Y. 2, for example, is at different speed. Okay, it's too fast. 1, 2, and here 1, 1. Oh, no difference. 0, 0. Okay, now it's a little slower, but you see, anything that you need to require animation, you would do on the loop method, on this loop function here that we created. And yeah. So, of course, we have much more to cover than what I just showed here. This was just intended to be a very simple introduction to THREE.js, so you can understand roughly how the things are put together. So, on the next lessons, we're gonna go deeper a little into this. We're gonna break down the code into modules. We're gonna abandon JavaScript and move to something like a TypeScript. I wanted to create this project as real life as possible, as closer to real life as possible, using the technologies that I would be using if it was for a client or even if it was for myself. I will try to cover you like in real depth what are the tools and the ways that usually people are coding with these technologies. And so this would give you a better hint on how to do exactly the things instead of keeping being a beginner forever. Yeah, so see you on the next lesson.